Okay, welcome to all of you. Welcome back. Hopefully the weekend was wonderful. It was probably our last really warm weather weekend for a long time, maybe until May, because things are changing for next weekend they're talking about, but we'll see. Let me talk about the plan today. And what we're going to start out with is I'll go over the exam and go over at least some of the answers. We'll see how many you guys want to see. And then I'll answer any questions that you might have. And then we're going to move to a section that is, it's a theoretical section. So I want to give you a warning. Some people like it, some people don't, but it might be tough for you, but at least there's not going to be too much hard derivatives to do, but it's going to be a lot of theory. So that's just a little warning about today. And we'll start out with Rolle's theorem. So that's a theorem about knowing when the derivative might be zero. Okay, actually being guaranteed the derivative is zero. And then what we'll do is we'll get into the mean value theorem. And basically says that if you look at the average velocity, then there will be some time where you're going to be at the instantaneous velocity. And that's the mean value theorem. And then we'll look at a theorem that says that if the derivative is zero everywhere, then the function must just be a constant. And then we'll look at another theorem that says that if two functions have the same derivative, then they differ by a constant. And then finally, we'll look at basically defining what it means to be increasing or decreasing based on the derivative. Notice something that's not on the list of things to do today. Do you notice anything?
Quiz?
Yeah, there is no quiz today. Because if you notice, we didn't have a section due today. Okay, I wanted to really focus on reviewing for the exam on Wednesday, so we just didn't do new stuff on Wednesday. So there is no quiz today, but we still have a lot to do, but no quiz. So how come it says there's a quiz today? Let's see, I didn't say so. Let me see something. If it says it's going to be deleted because there should be no quiz today. Let me get to, wait, not that one. That one. Hopefully this will allow me to do it. So in terms, I want to mention a few things while we're here. Yeah, it does have the quiz, but the quiz basically was the last quiz. Notice they're both 4.3. So we already did 4.3, so there's no reason to have a second quiz on 4.3. Yeah, so that's kind of what we did. So there's not going to be a quiz today, just let you know. So that's the good news. There is no quiz. But I do want to mention a few things. One is that a week from Wednesday is Veterans Day. And even though we're online, I think we should all have a vacation. So if you don't agree with it, then I don't know, work by yourself, because I'm not going to be doing a class, and hopefully you're okay with that. So I believe in honoring our veterans. And so that's 11/11 is Veterans Day, and we're celebrating it on the true Veterans Day. So that's just a big note, is a week from Wednesday will be Veterans Day. So plan on that. If the weather's right, I'm going to do something fun. We'll see how it goes. So that's just something in the calendar. I'll mention that, ahead of time again too. So, and then a few more weeks, we got Thanksgiving. So holidays are coming. We haven't had a holiday yet, but it will happen. Okay, so that's the plan for kind of upcoming quarter. So let me get to the exam. Okay. So the idea here, what I want to do is I want to not necessarily do every detail of every problem, because I think that might take an hour. And I don't know if you guys want me to spend an hour going over the exam and then having to rush through the next section, which could be tough. But what I'll definitely do is I'll take requests. So if you have a request to see an exam question, I'll definitely go through it. I hope you all know how to write down your name. So I think I'm going to skip number 1. And you all got the number 1 right. That was good. But I do want to mention things about kind of where people had difficulty on the different questions in the exam. So the first real question, question 2, was that if f is e to the x tangent of x minus 3 root x plus sine inverse of x times secant inverse of x, find the derivative. And some of you got it right, which is great. I think the number 1 place where people made mistakes was understanding and remembering this inverse sign. This does not mean 1 over the sine. Okay, it does not mean you take the derivative and you say -1 sine to the -2. That's just wrong, right? So who remembers the derivative of the inverse sine? Hopefully some of you. I know it's been 3 days since you took the test, but you needed to know it for then because there was a lot of things to remember. So what was the derivative of the... Yeah.
1 over square root of x squared. Oh, sorry. 1 over the square root of 1 minus x squared.
Good. So where people made mistakes is they didn't do that. So I'm going to do the third part. If you guys want to see me do the product rule for the first one, which most people got that right, or the power rule for the second term. It was the third term where people had problems, and that was, and let me just copy it. I think it's the easiest. And I'm just going to do this part. Whenever I do a product rule, since it's the first times the derivative of the second plus the second times the derivative of the first, then it's easier to just copy and paste it twice. Put a plus in and switch what we need to switch. So we can take a derivative. If you want to take the derivative of the first, you can. And we already said that the derivative of the inverse sine is 1 over the square root of 1 minus x squared. And then we got to find the derivative of the inverse secant. And again, that I told you had to memorize those. So there are a few things in this class you have to memorize. And the derivative of the inverse secant has a 1 over, and that's going to be x times the square root of x squared minus 1. And that's that part of that problem. Anybody lost on what I just did? Using the product rule and the derivatives of the inverse. Any questions on that? Okay, and of course this isn't the full answer, but it's the part where most people had trouble. And I never know where everyone's going to have trouble when I write the test, but I find out when I grade it. Any questions? Okay, let's look at the next one. The next one, I'll tell you, there are 2 ways of doing it, the easy way and the hard way. The easy way is the quotient rule. The hard way is to write it as an ln of x to the -1. If I remember right, I don't think anybody got it right when they did it the hard way. So I think I'll do this because a lot of people didn't want to use the quotient rule. And I'm going to tell you, quotient rule is so much easier, so use it. Okay. The only time you don't use the quotient rule is when you have a constant in the numerator or denominator, or if you just have a perfect power of a something, which we don't here. So what I'm going to do now is use the quotient rule. And that just says that f prime. And hopefully y'all remember the quotient rule because you needed it. We take the low and copy and paste ln of x. Times d high. And the derivative of 1 is 0. Derivative of negative is still negative. Derivative of the inverse hand is 1 over 1 plus x squared. So we just get -1 over 1 plus x squared. And then it says minus, so we just did the low d high minus high. So that's going to be 1 minus tan inverse of x is the high times d low. And what's the derivative of ln of x? One over x. So this is not a trick question. And then you're supposed to square the bottom. So it's ln of x squared. Do I require you to simplify this? No, you're done. You should definitely hit the insert equation button. And that's it. So do I make it look easy or was that hard? Any questions on that? I make it look rapid. Yeah, I'm going pretty fast. Tell me to slow down if I do a step that was too fast for you. Because again, it was a 2 hour and 40-minute test. If I did it your pace, then we don't have a lecture at all, and we need to have a lecture. But any questions on that problem? Okay, the next one. This one, some people got it right, but there was one big problem that people had, and that is the derivative. I think all of you, if I remember right, knew to use a chain rule, or just about all of you knew to use a chain rule. Most of you had good ideas. The biggest problem was this secant. What is the derivative of the secant of something? What's the derivative of the secant of something?
Isn't it secant x tan x?
It's not. And that's what a lot of you made mistakes on. Let me write this out. I know you're going to laugh when I write it, but I'm going to write it anyway. So if we want d over dx, not d over dx of the secant of something, that is not secant of x times tangent of x. It's secant of something times a tangent of something times the derivative of something. And that's where people made mistakes. Something in this question is not x. What is something in this one?
Cotangent of cosine of 3x.
Exactly. And that cotangent of cosine of 3x needs to go where you see the word something. You can't put x there. Does that make sense? That was the number one mistake people made in applying the chain rule, is you put x in instead of something. Okay, and the something in this case, I purposely wrote the word something because that emphasizes that it's not x. Got it? And that's cotangent of the cosine of 3x. Then we can quickly do it. Cotangent cosine 3x. So now I can replace that something with the cotan of the cosine of 3x. Then I can copy the cosine of the cotangent of 3x, cotan of the cosine of 3x, put that in for something. And then multiply by the derivative of the something. The cotangent is negative the cosecant squared of new something. So it's negative the cosecant squared of cosine of 3x. And then we got to multiply it by the derivative of the cosine 3x. And that's going to be 3 times negative sine of 3x. Any questions on that? Okay, and that's how you apply the chain rule. Okay, let's look at number 5. So for number 5 is we want to find the derivative of the inverse function at x equals 2. Okay, now if you remember, and some of you did, some of you didn't, but it was important that you did, is we had a formula for the derivative of the inverse function. Who remembers what that is? And I will let you know this stuff comes back on the final, so still got to remember it, even though the test is over. What's the derivative of the inverse function in general?
1 over f prime of inverse f of x.
Good. All right, so I like to look at the step-by-step process to get that down. So step 1 is what is just f prime. So let's write that out. So we know f of x was the cosine, oops, do this again. So f of x is the cosine of pi x over 2 minus x squared plus 3. Let's just take its derivative. So f prime of x, well, we got to use a chain rule. Derivative of pi over 2x is just pi over 2. Derivative of the cosine is negative the sine of the something, which was pi over 2x. The derivative of x squared is 2x. And derivative of 3 is 0. Any questions on just finding the derivative of f of x? That was step 1. Step 2 is to try to find the inverse when x is 2. So in other words, we need to find a value of x that gives us 2. And I promised you it wouldn't be some kind of weird, brutal number. You could try 0 first. If you plug in 0, then you get cosine of 0, which is 1, minus 1 plus 3. Does that give you 2? So if you plug in 0, do you get 2? Okay, let's look at it again. Okay, so we have cosine of 0, which is 1, minus 1 squared plus 3. Well, 1 minus 1 plus 3 is not 2. Okay, again, you don't need a calculator for this. I mean, it's just very basic arithmetic. What's the next hopeful number to plug in after 0? One. So let's try 1. Cosine of pi over 2, that's 1, minus, cosine of pi over 2 is 0, minus 1 plus 3. What does that give you? That gives you 2. So if f of 1 is 2, then f inverse of 2 is 1. So I'm just going to write that down. So f inverse of 2 equals 1. Very quick. Okay, and I promised you it would be either 0, 1, or negative 1. I don't know if you remember that, but I basically gave you that promise when I talked about the stuff on testing. In the real world, you're going to have to use calculators and stuff to find the inverse, but here I gave you easy numbers. All right, so that was step 2. Step 3 is to plug in. So f inverse of 2 is 1. So we need to plug in f inverse of 2 into f prime. So we need to find f prime of 1. So f prime of 1, what do you see next? You put a 1. I lost the pi. Okay, and what do you get? It's not that beautiful, but it's not terrible. So hopefully you know what sine of pi over 2 is. Right, sine of pi over 2 is 1. So you just get negative pi over 2 minus 2. And I copy the negative pi over 2. Minus 2. Any questions on that so far? Okay, what's the last thing we need to do based on the formula? It's not hard, not even calculus. So it's the last thing we need to do. Yeah, we need to put it over 1. So I did this so I can just go do the following. So 1 over f prime of 1 is equal to 1 over negative pi over 2 up minus 2. And I don't require making it pretty or anything like that, but if you wanted to, you can, but it's not necessary. Any questions at all on the step-by-step process on finding the derivative of an inverse function? Again, if you know the steps, this isn't that hard, because step 1 is find the derivative, and this is just a simple chain rule. Step 2 is find out what value gets you that number. So to find the inverse. Step 3 is to plug in, and step 4 is to take the reciprocal, and that's it. Okay, question 6. Find the equation of the tangent line at the point 2, 0. Okay, so what is the first step when we have this kind of function, well, this kind of equation? What's the first step? Yeah, implicit differentiation. So I'm going to quickly do that. So what rule do I need to use for x e to the y? The hint is it's a product rule. So the derivative of x is 1. Derivative of e to the y is e to the y times y prime. And don't forget, you need the chain rule because we have a y and not an x. Okay. And then similarly, we need the double chain rule with the sine. So the derivative of the sine is the cosine, but we have to have a 3, and then we have to have a y prime. So we can have a 3y prime times the cosine of 3y. Derivative of x squared is 2x. Derivative of 6 is 0. Any questions so far? What's the next step? And some of you did the hard way. Some of you got it right with the hard way, but there's no reason to torture yourself. Yeah, we plug in. And I don't randomly put numbers down on these tests. I make them so they're nice, okay? Honestly, I don't even like using calculators. You thought it was fun to solve for y prime. No, thank you. I have fun in better ways like hiking. But I'm going to just plug in. And the nice thing is e to the 0 is 1. Okay? And cosine of 0 is also 1. That gives us nice ones. So let's copy that. And then I'm going to plug in. So y is 0, x is 2. So this e to the y becomes 1. X e to the y becomes 2. 3 cosine of 3y becomes 3. 2 times 2 is 4. And that is so much easier than solving for y prime at the first step. Okay, and then I can do the rest in my head. 4 plus 1 is 5. And then 2 minus 3 is negative 1. So you just get 5. So y prime equals 5. And we're not quite done yet, but we've done the hard part. Okay, so the last thing, because the question says, find the equation of the tangent line. They just use the basic formula, y minus y1 equals mx minus x1. So we just have y equals m, which is 5, times x minus 2. That's all there is to it. Any questions? Any questions on this question? Number 6? Okay, let's move to number 7. Number 7 is really easy if you just remember the language, but if you don't, you won't get it. So the manager of the Tahoe Blue Hotel has determined the revenue are per day for the hotel when there are X guests is this function. What's the marginal revenue when the hotel has 80 guests? What's another word for marginal? What's our word for marginal? Yeah, this just says find the derivative, set it, plug in 80. Okay, so the derivative is just, do you know the biggest mistake? I kind of laughed at it, is multiplying 2 times 0.05. I did not expect that to be the hardest part of this problem. But that's where a lot of you had trouble with. And 2 times 0.05 is 0.1. Okay, so that's just a note. And again, I can't anticipate that was going to be tough. Okay, and I don't know why that was hard. I don't think I did some weird thing in class or something to do 2 times 0.05 and show you something different. But that's supposed to be 0.1x. And then plus 100x, derivative of that is just 100, and 70 goes away. And then the last step is you just plug in 80. One behaves differently under the clock. That could happen. Okay, so you plug in 80. 80 times 0.1 is 8. 8 plus 100 is 108. So 108 is the answer. I guess on this, I should write r prime. So the answer is 108. Any questions on that? I consider that to be the easiest problem on this test. I don't know if you agree, but I thought this was supposed to be the easiest problem, but sometimes that doesn't always happen. I never know what goes into your minds. Okay, the next one is the following. And it took me so long to find the distance between Cave Rock and Emerald Bay online. And I finally had to go to a map and estimate, but it looked like it was about 16 miles. So Cave Rock is 16 miles northeast of Emerald Bay. At noon, a kayaker paddles from Emerald Bay, heading due east at 3 miles an hour. And a paddleboarder paddles from Cave Rock, heading due south at 2 miles per hour. how fast are they approaching each other at 1:00 p.m.? Okay, so I tried to give you a realistic problem. What I have no idea what happened is that you guys aced the quiz question that was related to rates. And then you had a lot of trouble with this one. And I didn't think one was harder than the other, but for some reason you didn't like this one. And the first step, which I did ahead of time, because honestly, it's pretty hard to get a picture. And I didn't require you actually having a pretty picture like I have, but it helps at least to talk about your picture if you didn't want to, do some kind of picture, which you can't really do. But you could do it on a piece of paper. So I figured I'd show you what you might do on a piece of paper. Okay. And what we have is we have Emerald Bay over here. We have Cave Rock up here. And then we have the kayakers going from Emerald Bay going that way. And the paddleboarders coming down that way. Okay. And they may or not meet. It doesn't matter, but at least you can draw the triangle. Any questions on this picture? And I just called this X and I just called this Y. And I guess I didn't put anything in here, but I don't know, call it Z or H. I don't really care, but give another letter because that's what's changing. Any questions with this picture? Okay, and it is a right angle because I told you it is northeast, and northeast does a few things for us. One is we can draw this right triangle, and it's a true triangle because one is going south and the other is going east, and the other is that the original triangle, because it's northeast, is isosceles. Any questions on the fact that this is an isosceles triangle? Okay, what we're given, because that's the next step, is we know that the paddler from Emerald Bay is going 3 miles an hour. And we know that the paddleboarder is going 2 miles an hour. Okay, any questions on that? Okay, and sorry for the bad grammar, it should say 2 miles an hour, but I don't think that was where you had troubles. Okay, so let's write that down. The going at 2 miles an hour or 3 miles an hour, that's a derivative, right? Per hour means derivative. So that means that we have dx over dt is 3 and dy over dt is 2. Let's write that in. So dx over dt was 3. And dy over dt was 2. And what we want, and maybe I'll call it z, it doesn't matter what letter you call it, we want dz dt, because that's how fast they're getting closer to each other. And that's dz over dt. I'll put equals question mark. Okay, what is the big formula that I do require you to know that involves right triangles? Hopefully you all know it. You better. Some people consider it the most important mathematics formula there is. Yeah, it's a Pythagorean theorem. And well, you have some interesting letters in your expression. I'm going to use our letters instead of h a couple times, but I'm going to use x squared plus y squared equals z squared. So we know that x squared plus y squared equals z squared. And then we implicitly differentiate. And what we get is the derivative of x squared is 2x dx dt. And then the derivative of y squared is 2y dy dt. And the derivative of z squared is 2z dz dt. Any questions on that piece right there? And then we plug in. We know dx dt is 3. We know dy dt is 2. And how do you find x and y? That takes a little bit of work, but it's not too bad. You have to give the information. And we have to give the fact that it's 1 o'clock p.m. At 1 o'clock p.m., first thing is that at noon, the horizontal distance and the vertical distance are the equal. So that means 2 times that distance squared. So it means that 2 times the distance squared is 16. Because we could say, I don't know, a squared plus a squared is 16 squared, which is 256. So that means a squared is 128. So a is a square root of 128. That's the initial piece, is a square root of 128. Then what you do is you say, well, how do you find out what x and y are? Well, x is going to start at the square root of 128, but then get decreased by 3. So it'll be root 128 minus 3. And y, similarly, you'll start at root 128 and get decreased by 2. Then what you do is you find your z by the Pythagorean theorem with what we just did. Gives you somewhat messy numbers, but it works out. And that gives you your x, y, and z to plug in. We know dx dt is 3, dy dt is 2. And then basically you just quickly solve for z. So the rest is pretty basic, a little messy, but basic. I don't think I'm going to waste your time in all the messiness of the roots and stuff for typing. But any questions at all on this problem? Any questions? Okay, let's move to number 9. Because again, I don't want to spend the whole hour and 45 minutes on that. Don't understand how you got x and y? Okay, so again, we look at this. Look at the black triangle. So I'm going to call A the base and the height of the black triangle. And remember, it's an isosceles triangle because we're talking about northeast. Northeast means it's isosceles. Okay, so if A are the base and the height, that means from the Pythagorean theorem, a squared plus a squared is 16. So maybe I'll write that out if I lost you, because I talked a lot and that's sometimes tough. So we know a squared, maybe I'll use lowercase a because it's not area. A squared plus a squared equals 16 squared. So that means that 2a squared is 16 squared, or a is equal to the square root of 256 over 2, or the square root of 128. Do you understand that so far, Alexi? Okay, then something very simple. In the instructions, we're looking at 1 o'clock p.m. 1 o'clock p.m., hopefully you know, is an hour afternoon. In an hour, they went 3 miles east. Got it? Yeah, you just had trouble with the Pythagorean theorem in the first step and knowing it was isosceles. Yeah, so then we just subtract 3, and that gives you your x, and subtract 2, and that gives you your y. Okay, and then a messy Pythagorean theorem to get your z. But it's messy with numbers, not necessarily conceptually hard. Okay, now let's move to number 9. So number 9, you're going to be emptying a 10-meter high cylindrical water tank that's full of water. You measure the radius to be 4 meters, and the maximum error is 0.05 meters. Use differentials to estimate the maximum propagated error in determining how many cubic meters of water the tank holds. Okay, so the idea here is we have our big volume formula. There's a cylinder, and the volume of basically anything is the base times the height, the area of the base times the height. So if you didn't remember that volume of a cylinder, you just got to remember base times height. So we know the volume is equal to the base. The base is, well, it's a circle base. It's a cylinder. That's pi r squared. And the height doesn't change. The height we know, there's no error in the height. And the height was given as, I think, 20, if I remember right. But if not, I'll change it. Times 20. Oh, 10. I was wrong. So it's a 10-meter high cylindrical tank. That's better. Any questions on that? And then we're supposed to use differentials, and the differential formula says we had V equals, let me retype it, V equals, I'm going to write 10 pi r squared. So we take a derivative, and we take a dv, which is slightly different than the derivative because when you take a dv, you have a dr on the right. And the r squared becomes a 2r, and 2 times 10 is 20. I did remember the 20, but I remembered it too late in the problem. Have I lost anyone there? This is one of those problems that's easy if you know what to do, and if you don't, you have no chance. Okay, so our radius is measured at 4, but the error is 0.05. So just plug in 4 and 0.05. So R is 4, and dr is 0.05. And that's 4 times 0.05 is 0.2. 0.2 times 20 is 4. Is that right? 88 times 5 is 40. Yeah. Any questions on that? Okay, that was part A. Part B is relative error. So we want the relative error. So to find the relative error, that's dv over v. And we could just use 4, but it's actually easier not to. So dv, let's write this out. If you remember, that was 20 pi r dr, and v is pi r squared. And that simplifies very nicely because the pi's cancel. Okay, and not only that, an r cancels, and you just get 20 r over dr. I'm sorry, 20 dr over r is what I meant. Any questions on that? Okay, then I just plug in. dr was 0.05, r was 4. 20 over 4 is 5. 5 times 0.05 is 0.25. Any questions on that? Let me double check. 20 pi r squared over dr. And pi r squared, r's cancel. Yeah, that looks 5. Yeah. Okay, so then what's the last step? For part C, what's the part C step? Very easy, I'll let you tell me. So what's the last thing we do? We want to estimate the maximum percent error. Yeah, just multiply by 100% and you get 25%. And that's it. Okay, number 10 is we have a function. We want to find the critical points. So a lot of you missed the first step. What is and I gave you a step-by-step process of finding critical points. What's step 1 on finding critical points?
Find the derivative.
That's step 2.
Oh.
What's step 1? The most people forgot step 1. Yeah, determine differentiability. Okay, so we look at this function 1 plus 8x plus 200 over x. Are there any values of x where this function is not differentiable? Yeah, so 1. X equals 0 is a critical point. I'll just write CP for critical point. Most of you forgot that. I'm not sure what to say, but it is the first step. You need to decide when it's differentiable. Step 2 is find the derivative. And again, I tried not to give you a hard one. This is not a hard derivative to find. I tried to make it so that the first questions were the hard derivatives. We had to use product and chain and multiple chains. These should be pretty easy. Derivative of 8x is 8. Derivative of 20 over x squared is the same as the derivative of 20x to the negative 2, which is minus 20x to the negative 2. Or if you want 20, it's 200, sorry. 200 over x squared. And that's the derivative of f. What's step 3? Yeah, we set it equals 0. So we take that derivative, we set it equal to 0. Try to give you a nice one. So that means if I multiply by x squared, I get 8x squared. Minus 200 equals 0. Add 8. Add 200 divided by 8. We get x squared equals 200 over 8. 200 over 8 is equal to 25. So some people had trouble in solving x squared equals 25. I never know what's going to be hard on a test. I didn't think that was going to be hard. But if x squared is 25, what can x be? What are all the possibilities for x? All the possibles. Yeah, 5 and negative 5. Okay, so there are 3 critical values. So it's not just 5, it's 5 and negative 5. So in particular, the critical values or critical points are at x equal 0, -5, and 5. Any questions on part A? For part B, now we're looking between 1 and 10. Let me just rewrite that. And then we had a big theorem that said that the maximum and minimum, the global max and min always occur either at critical values or endpoints. Now, we're only allowed to be between 1 and 10. So the possibilities are x equal 1, 5, and 10. -5 and 0 are not in the interval, so they're not even possibilities. And then f of 1 is equal, let's get that f back. So f of 1 is just 1 plus 8 plus 200, which is 209. F of 5 is equal to 1 plus 40 plus 40, which is 81. And f of 10 is equal to 1 plus 80 plus 20, which is 101. So now it's very easy. What's the global global minimum? Often called absolute. I don't remember what I call it, what I ask you. Absolute. Yeah, absolute minimum is 81 and at x equal 5. And absolute max. What's the absolute max? These aren't trick questions here. Yeah, 209 at x equal 1. And that's the answer to that question. Any questions on that? Okay, then the last couple are true, false. And I was kind of a little disappointed. You know, I never know what you guys are thinking. Maybe it was towards the end of the test and you were tired. But if you want to find out where the critical points of a function are, and it's differentiable, because we're told that it's differentiable. What are the steps in finding the critical points? What's step 1 after checking step 2? Sorry, step 1 is it's differentiable, so there's nothing there. Step 2 is find the derivative. I was a little disappointed that you didn't find the derivative. H prime, what rule do you have to use to get the derivative of f times g?
Product rule.
Product rule. Well, we take f prime times g plus f times g prime. But we're plugging in 3. And we know, so now what we can do is we can plug in 3 into this product rule. Yeah, if you write power rule instead of product rule, it's not great. I'm not going to give you 0 out of 10 or anything, or 0 out of 5, but I might take a point off for writing down the wrong rule. Because that is a calculus. If it's a calculus error, and that's a calculus word, not spell check, that's a calculus error. If you spelled product rule PRODECT, I wouldn't take any points off. But if you call product rule power rule, that's not good. Just let you know for my grading. Okay, so we're supposed to plug in 3. Well, guess what? I plug in 3. All the x's become 3's. Nothing magical here. But we know that g of 3 is 0. So this is equal to 0 plus, and f of 3 is also 0. And you better all know what 0 plus 0 is. It's 0. So if the derivative is 0, then it's a critical point, and this is true. Okay, without doing the product rule, you really can't know this is true. I think there were more people that thought it was false. And this wasn't a trick question. You just do the product rule and plug in, and that's it. Okay, let's look at 12. So 12 is f of x equals x to the x. Then f prime of x is x times x to the x minus 1. So the question is, can you use the power rule? And the answer is no. And here's the reason. Okay, we have x's in the power and not numbers. Instead, we take the derivative by logarithmic differentiation. So let me rewrite f of x. And let's look at f of x as x to the x. But then we can say, I'm going to call it y as fewer letters. Okay, and we can say that ln of y equals ln of x to the x, which is x ln of x. Any questions on that? All right, well, then we take a derivative. So the derivative ln of y is y prime over y. Derivative of x ln x, that's product rule. Product rule came up a lot in this test. And I don't think that was tricky because product rule was a biggie in this particular last 3 or 4 weeks. So we take the derivative of x, which is 1. We take the derivative of ln of x, which is 1 over x, and 1 over x times x is just 1. So we get that. Then we multiply left and right by y, and remember y is x to the x. So we get y prime equals ln of x plus 1 times x to the x. Is that the same as x times x to the x minus 1? Definitely not. Okay, and in fact, x times x to the x minus 1 is actually just x to the x. And ln of x plus 1 is not just 1 because that would make ln of x always 0. It's not. So it's false. Any questions on that? Any questions? Okay, so that was the exam. I want to remind you, let me go to the syllabus. I want to read something very important that I read on the first day of class, but it's time to read it again. And that is, if all homework assignments are turned in for the quarter and no more than 3 assignments are completed with a grade of 5 or less, then the regular exam with the lowest score will be dropped. Okay, so that's just a note. So if you have, by the way, if you have two 99%, you actually don't even need to take the third exam as long as you do all your homework and, get at least, 6 out of 10 on all of them, or 6 out of 10 on all of them. Okay, or 50. When I say 5, I mean 50%, by the way. Okay, so that's just a note. On the other hand, if you didn't do well on one, then work your butt off so you do well on the third one so you can drop the one you didn't do well on. No, this is homework assignments, which is, I know it's so confusing with this whole online thing. The word homework doesn't really work. I should probably replace that word homework with chapter assignments. Or section assignments would be better. Yeah, quizzes are different. So this is for the section assignments. Okay, hopefully that answers your question. Yeah, it used to be called homework when you actually did it at home and the quizzes were done in class, but there is no in class anymore. So sorry about that. It's just hard to get into the new framework of we can't be in college anymore. Any questions on this? It's very important because you know what you're getting yourself into. Okay, big motivator to make sure you do every single assignment. If you miss one assignment, then that's it. You got to do all the tests. Okay, and do well on them all. All right, now let's get to new material. First, any other questions? Because that's my new material. Any questions?
Larry, I have a question.
Sure.
So in terms of dropping one of the exams, if I wanted to say like drop the first one I took, I would have to take this upcoming exam in order to, and say I do well on the upcoming exam. Can I choose a different exam to drop then?
Okay, so I do the choosing, and trust me,
okay.
I choose for you. Okay, I'm not the bad guy. And here's how I choose. I look at the 3 scores and I replace the lowest by the average of the 2.
Okay.
The 2 highest. Yeah, so I promise you it's a good thing for you. It's never bad.
Okay.
Yeah. So that's what dropping means. Because again, there's lots of definitions of drop, but this is the most mathematical, logical definition of drop an exam. Okay, other questions? Okay, let's get to Rolle's theorem. Okay, so Rolle's theorem is very important, and it's not that hard. It makes total sense. I'm just going to state the theorem. It's an easy proof. That's the good news. But the even better news is I'm going to prove it. You're not going to. So, it's hard to prove on, especially on the spot. But you need to understand Rolle's theorem, and you need to be able to use Rolle's theorem, and hopefully understand what I did and why it's true. Rolle's theorem says the following. So the first thing, and this is very typical in this class, is we're going to start out with a function. Let f of x be not only a function, but I want it to be a good function. In this class, what did I mean by good? Yeah, differentiable. Okay, if you can't take a derivative, you just can't do anything for our class. So if it better be a differentiable function on AB such that, and this is the interesting thing, okay, it's not weird or anything, but let's suppose that where you start and where you end is the same. So in other words, f of A equals f of B. Okay, so it's kind of like, you take a walk and you start at elevation, 6,300, you go up and down a bunch, and then you end up with elevation 6,300. Okay, so that would be an example of f of A equals f of B because you started and ended at the same elevation. Does that make sense so far? Okay, now here comes the part that makes total sense if you're like me, and I doubt you're as much like me as I am, but I'm a super avid hiker. Okay. So I started at the car at the turnout yesterday near Luther Pass. And I did 10 miles of hiking. And then I ended up at the car again. Did I have a highest point? What do you think? Was there a time on my hike where I was the highest possible? Highest I was on the whole hike? Yeah. This is not a trick question. Did I have a lowest point? Also, yes. Okay. Okay. And by the way, my highest point was the global maximum in the Tahoe area. Okay. Of all of the whole Tahoe region. Just let you know that. But that's just an extra fun thing from yesterday. That's where I was yesterday. I was looking down at all of you. Okay. If you were in town. Okay. So I had a highest point and a lowest point. But more importantly for Rolle's theorem, when you're at the high point or the low point, what do you know about the derivative? What do you know about the derivative if you're at the high point or the low point? Yeah, it's 0. So that's the Rolle's theorem. So then there exists a C Let me do it this way, I think, if it allows me to have that symbol. Maybe I can't. Give me the symbol. There it is. A C in the interval AB. Such that f prime of C equals 0. So if you start and end at the same f value of f, then somewhere in between those two, you're going to have derivative 0. And that's Rolle's theorem. And if you're a hiker, it's obvious, but that's not a proof, by the way. But it's kind of similar, though. I mean, kind of the idea is how we're going to prove it. Any questions on Rolle's theorem? What it says? Okay, the proof is pretty simple. So I'm going to prove it. The proof has 2 cases. Okay, and actually, before I even say 2 cases, let me mention something. So by IVT, who remembers what IVT means? Actually, I think I'm not even going to do IVT. I'm not even going to do IVT, but you should know what that one is too. Okay, we know that there exists a global maximum and a global minimum for f of x between, so on the interval AB. Okay, we always know that. That was a theorem we had last week, is that for any continuous function, there's always a high and a low. So now I'm going to go into 2 cases. So case 1. Okay, so both the global max occur at the endpoints. Okay, that could happen. But what do you know? If we know that the left endpoint and the right endpoint have the same value of f. So they're the same elevation. So if I told you I started at the car and I ended at the car, and the highest and the highest and the lowest were both at the car. What do you know about my hike, by the way? Yeah, it was flat. Okay, and in math, what we say is then that would mean that f is a constant. If the max and the min are the same number, that means you never go up or down, you just stay there. So then f of x is a constant. I'll just write equals k for some constant. But now what I'm going to do is just let c be anything I want it to be. I don't even care. Oh, how about c equals a plus b over 2? Okay, nothing fancy about it. You could choose any number you want in between a and b, but I'm going to just pick the middle one. But it's definitely between a and b. But what is f prime of c? If f of x is k, what's the derivative? Yeah, it's 0. I'm done. Any questions on case 1? Case 1's easy. Do y'all agree? Okay, case 2. Well, if they don't both occur at the endpoints, that means that one of them has to occur somewhere else. So and again, it's somewhere else. I don't know where it is. I'm going to give it a letter. Any guess what letter I'm going to give it? As soon as I say, it'll be obvious. I don't see y'all jumping in. C. So let C be the x value of the global max or min that does not occur at the endpoint. I guess at an endpoint. It wants it one word. Well, what do we know? If you have a global max or a global min that's not an endpoint, what do we know about that we had last week? If you're at a point that's a global max or a global min and it's not an endpoint, what do you know about that function? Yeah, it's a critical point. And by definition, if you have a differentiable function, since f is a differentiable function, then a critical point means f prime is 0. And that's it, we're done. Those are the possible two cases. And either way, sorry, that should be C, not X. Either way, we found a C between A and B where the derivative was 0. Okay. So we know that has to happen. Does this mean there's exactly one C such that the derivative is 0? Yeah, definitely not. In fact, on my hike, there were probably 30 or 40 that were the derivative of 0 because there were a lot of ups and downs. Okay, so you could have lots of places, but we always know there's at least one value of C, one value of X, where the derivative at that value is 0. And that's Rolle's theorem. Any questions on this? Any questions? Okay, so this is really important. Okay. By the way, one of the big applications, I don't think I've mentioned it, in finding the maximum or minimum is artificial intelligence. And it's all about searching for that C. And again, there's huge amounts of money made and very important in this modern society to know how to do that. Not very important for every general person in the world, but if you know how to do that, you'll be making well over 100,000 a year in your first year of work. Just give you an idea. So if you want to make really good money, but you got to be good at it, that's the place right now. Okay, you'll have dozens of companies trying to hire you. So it's a big deal finding where this derivative is zero. And it turns out, and it's something I mentioned a while back, is this class only does one variable calculus. In the real world, you need to do more, but it's still going to be a derivative of zero, but then it's at a point with many variables. But we're only going to do one variable. Any questions on this? All right, now I am going to I'm going to do a little scenario. And here's a scenario. Okay, you are driving from Myers to State Line. Okay, which and along Pioneer Trail, that's the fastest way, especially if you're in a hurry, because there's hardly any lights. And all the locals know that, but the non-locals don't. Okay, so that's the first thing. Okay, who knows how far it is from Myers to Pioneer Trail? And Myers to State Line along Pioneer Trail? You don't have to know, that's okay, but I looked it up, which is 8 miles. Okay, can you all picture this? Okay, by the way, what's the highest speed limit? What's the highest speed limit on Pioneer Trail? Nope. Nowhere on Pioneer Trail you're allowed to go 55. Yeah, 50 is the highest. Okay, so note that the highest speed limit is 50 miles an hour. All right, what you don't know is hidden at the beginning. Actually, you do. And end of your journey are cops. The first tracks you going. So you see the cop. So if you see the cop, how fast do you think you're going to go? Okay, 49 actually in Myers, probably 40. Because remember, the speed limit does change. The highest was 50. Okay, so let's go 40 miles per hour. Okay. At 11 o'clock a.m. The second tracks you. Okay, the first tracks you going at that, and I should say at the beginning of your journey. The second tracks you going, okay, now you're by State Line, so you better not even be going 40. How fast are you allowed to go by State Line? Yeah, 35. At 11:08. All right, now here's the question. can they give you a speeding ticket? Okay, and we're going to make some assumptions. We're going to assume that if they give you a ticket, then you're always allowed to complain about it and argue at a court. And we're going to assume, which is a big wrong assumption, that everyone in the jury knows calculus. Okay, good luck. All right, can they give you a speeding ticket? So if you had to be the lawyer for the cop, or you had to be the lawyer for the driver, who would you want to be the lawyer for? What do you think? Can they give you a speeding ticket? Okay. So I'm seeing no. So here's how that, let me tell you how the court case will start. Okay. The defendant always gets to start, I believe. I think so. I'm not sure. I'm not a lawyer, by the way. And the idea is the defendant is going to say, look, hey, I was going 40 miles an hour. I was going the speed limit when the cop saw me. And when the second cop saw me, I was going 35. I was going the speed limit exactly. I wasn't speeding. Sounds good, doesn't it? Okay, now that's the lawyer for the defendant. Now the lawyer for the prosecution. How is that going to change? So what is the argument that the person was speeding? Okay, and here's the argument. The argument starts by citing a theorem. Okay, this is why very fictitiously you have to assume that the entire jury understands calculus. Okay, but we're going to do it. And by the way, do you think I've ever been an expert witness doing calculus in a court of law? What do you think? You think I've ever done that personally? Okay. And the answer is yes, actually. It was a long time ago, and it was something very similar to what we're doing right now. Okay. And here's how it works. And this is called the mean value theorem. It turned out not to go to court. I was the expert witness, but I wrote my whole mathematical proof that there was an issue. And I wasn't the lawyer, but they were able, based on that and some other things, they actually settled out of court. But I was part of it. It was kind of cool. So the mean value theorem says the following. So let f of x. If we want it to be a good function, what should we say? What's a good function in this class?
Differentiable.
Yep. Function on AB. So let's suppose we have a differential function on AB. By the way, is driving, the position versus time driving in a car, is that a differential function? You tell me. What do you think? Is driving on Pioneer Trail a differential function where the independent variable is time and the dependent variable is mileage? Okay, the answer is yes. If you think you can go from, say, 30 miles an hour to 50 miles an hour without time changing, you're wrong. I don't care how good a car you have, it's not going to be able to do that. Okay, driving is very much a differentiable function. So that's it. So that's an example of one. So we have a differential function on AB. such that, guess I should say this. Actually, I don't even need such that. Then there exists a C. We've seen that before in the last theorem. That sits in between A and B. So in our case, we're going to say there's going to be a time between 11 o'clock and 11:08. Okay, such that now it gets interesting. F prime of C. By the way, in our example, what do you call F prime of a number? Starts with an S. You should all know this. Speed. Yeah, speed. So F prime of C is equal to F of B minus F of A. Oops, one more time. F of B minus F of A all over B minus A. This is a mean value theorem. Very important theorem. And it does make sense if you understand what this is. So first thing, F of B minus F of A over B minus A. We've actually seen that before in the first day of class. What is that? In a few words. Yeah, the derivative of the secant line. So what this says that if you look at a function and you look at the endpoints of the function and you connect them with the secant line, then there's going to be a point somewhere in between such that the slope of the tangent line equals the slope of that secant line. Okay, that's what that says mathematically. Now let's see what it says in terms of our example. Now what it says, F prime of C is a speed. So it says that somewhere in between Myers and state line, the speed of the vehicle was F of B minus F of A over B minus A. Well, F of B minus F of A over B minus A, okay, well, that's going to be the 8, because we said that it was a distance of 8 miles, and F is the miles. Okay, so that's going to be 8 miles divided by B minus A. Well, 11:08 minus 11 o'clock is 8 minutes. So that means that sometime in between Myers and state line, that car was traveling exactly 8 miles per 8 minutes, which, by the way, is 60 miles an hour. So, can the person get a speeding ticket? Okay, that's a trick question. The answer is no. You can prove the person was speeding, but you can't give them a ticket. And that actually is called law and not math. But what you can do is you can prove the person was speeding, and then if somewhere along the line that person gets in an accident, you can say that the person was speeding and therefore the person was dangerous on the road, and then you can, make that person maybe pay more for the accident. That you can do in a court of law. You can actually prove the person was speeding and make them pay more in a liability case in an accident because the person was recklessly driving, going too fast. But it turns out you can't get a ticket that way. But you can. So in terms of law, so when I did the expert witness thing, it was more of the reckless driving idea. Okay, the person didn't get a speeding ticket. Any questions on that? Again, you don't have to understand law. I don't care about that. But you do have to understand what this mean value theorem says. Any questions at all on the mean value theorem? Okay, so the mean value theorem is important, and I gave you an example. Let's prove it. Okay. And by the way, this is, if you're ever bored, this is what I do when I'm bored, is I sit there and I try and reprove all the calculus theorems just for fun in my head. So you might want to try it sometime. You might have fun like I do. But that's what I do. So I could do this like in my sleep because it's just something fun to do. So here's the proof. Well, guess what theorem we're going to be using to prove the mean value theorem? Here's a hint. It's on our things that we've already done today, and we haven't done that much today. See it? We're going to be using Rolle's theorem. So Rolle's theorem is going to give us the mean value theorem. So let me show you how. And the hard part is to come up with the right thing to get Rolle's theorem out of, because we need a function where we start and end at the same place. And here's what we do. So and again, this takes some thinking. And the idea here is that we basically kind of write the equation of the secant line. And that is, we're going to take the slope, which is f of b minus f of a over b minus a. So let me do this. So I have to do it again. So let h of x is equal to f of b minus f of a. Now think about the slope times x minus a. And the idea here, that gives you the slope times x minus a, but then we need to take that and we need to subtract f of x minus f of a. Okay, this is probably where I wouldn't expect you to necessarily, figure this out, but you can kind of see the slope times x minus a, and then minus or plus something. And that's kind of the equation of a tangent line. Okay, so now what is, just to note, because it's easy, what is h of a? I'm going to take a look at it. Tell me what h of a is. Plug it in. You should be able to do it in your head. It's real fast and easy. So x is a, that means, right? So what's h of a? So take a look. I promise you it's not hard. So h of a, you just plug in an a for x. Where you see an x, you put an a. That's a hint. Take a look at that. If you plug in a, what do you get? In that part, at least. Yeah. How about here? If you plug in a, what do you get? You get 0 again. So guess what? You get some number times 0 minus 0. Guess what? That's 0. Everyone good with that? What is h of b? So now we're plugging in b. We see a b minus a here. We see a b minus a here. The b minus a's cancel and you get f of b minus f of a. And then we're subtracting f of b minus f of a. Well, what do you get? You get 0. So in particular, hopefully you know, if h of a is 0 and h of b is 0, then very easy to conclude that h of a equals h of b. Because 0 is 0. Note, by the way, f is a differential function. So h is also differentiable. It's messier, but there's nothing to go wrong. You're just adding and multiplying by stuff. So h is differentiable. H of a equals h of b by Rolle's theorem. That means there exists a C such that, oops, where am I? There we go. Such that h prime of C is 0. Any questions on Rolle's theorem statement? Okay, and C is between A and B. I didn't write that, but I'm just going to say it. All right, well, now just plug in. So that means 0 equals, okay, notice this is f of b minus f of a over b minus a times x minus a. That's a line, this part of it. Okay, the derivative of a line is its slope, which is just f of b minus f of a over b minus a. So that part is just going to be the f of b minus f of a over b minus a. And then we're going to have a minus. Now we're going to take a derivative of f, that's f prime. What's the derivative of f of a? Hint is it's really easy. And actually, I'm supposed to plug in c, not x. Derivative of f of a is 0. F of a is a number. So I just get 0 equals f of b minus f of a over b minus a minus f prime of c. And I'm done. I just add f prime of c to both sides and I get what I want. And that's the proof of the mean value theorem. Any questions at all on this? Okay, quickly, couple more theorems that are simple. These are the biggies though, and now I'm going to give you some consequences. Okay, one is that if we have a function such that f prime of x is equal to 0 for all x. So it is the 0 function. What can you say about that function? If you have a function where you always get 0 for the derivative, what do you know? Yeah, the function's a constant. I guess a comma, not a period. So if we have a function whose derivative is 0, period, is 0 function, then that function must have been a constant. Is just some constant k. Any questions on that? Why is that true? I don't have time for a proof writing it down, but I can kind of talk it over. If you think about it, well, if it wasn't a constant, that would mean there'd be 2 points, A and B, such that we know that f of A and f of B are not the same. But if f of B and f of A are not the same, then f of B minus A over B minus A is not 0. But if it's not 0, that means there is a point such that the derivative is not 0 by the mean value theorem. So therefore, there can't be an A and a B where f of A and f of B are different. Any questions on that argument? So it's a very important theorem. Okay. And in fact, I think I'm not going to use K. I think I want to subliminally give you another letter. And that's capital C. Okay. And that's because Bruce will be happy if I use capital C, because next quarter you're going to be doing capital C. All right. So that's one statement. Here's another one. If how about G of X and H of X are such that G prime of X equals H prime of X for all X. Okay, and sometimes it'll say between A and B, but either way. Then does that mean G and H must be the same? What do you think? Yeah, it doesn't, because for example, G of X could be 12 and H of X could be 1. They both have the same derivative, right? But here's what it does mean. If you subtract the two, it's a constant function. So then G of X minus H of X is the constant function. Okay, and in fact, oops, 2 does. So that means that G of X is equal to H of X plus some constant, C. Okay, and the easy way to do that is you just look at G of X minus H of X and take a derivative. You get G prime minus H prime, but G prime minus H prime is 0. So therefore, from that first statement, you get the constant. Any questions? So this is a really important theorem, that if you have two functions that have the same derivative everywhere, they differ by a constant. This quarter is not that important, but in January, it's the biggie. Okay, and at least if Bruce is like me, you will lose a point on every problem if you don't know this. Just about every problem needs this piece. Any questions on this idea? So do you agree today's kind of a theory day? Okay, so today is, again, lots of theory, no applications. I guess I did the police application, but today's the theory day of the whole quarter. Okay, we're about out of time, so I'm going to stop my share and stop my recording.